This is the video solution for question 6f. With this problem, we want to keep in mind that there are some additional terms that are being added to our product. So with a problem like this, we are going to create an area model, but only for the product to find an equivalent expression for the quantity 3a plus b times the quantity 3a minus b. So I'm going to begin with my area model for those two binomials. Drawing out my 4-box area model, binomial times binomial, 3a plus b, 3a minus b. Taking myself through the boxes, I'm going to start with the top left. 3 times 3, keep in mind, is 9. Keep the base, add the powers, a squared. Top right box is 3 times 1, or 3. When we run into two variables, we put them alphabetically is the best way. Moving on to the bottom left box, I'm going to keep in mind that I just wrote AB in the previous, and when I do 3 times -1, I get -3, and then I have an AB again, so we're going to keep it in the same order AB so that I can clearly recognize my like terms that are forming. Bottom right box, -1 times +1 is -1, B, since they are the same variable again, squared. Keep the base, add the powers. Last step is to combine our like terms. I like to do it on the diagram. That's the beautiful thing about an area model. So I have a 9a squared, top left box, a 3ab, and a -3ab. Same exact variables, same exact powers. Coefficients are the same value but opposite sign. What happens? We've seen this before. They cancel out. That leaves us with just the -b squared from the bottom right box. What I'd like to pause for a moment and point out is that the 9a squared minus b squared is the result of writing an equivalent expression for the binomial 3a plus b times 3a minus b. But we have yet to discuss these terms here. They need to come down. They have not been a part of our work thus far. So if we bring down those two terms that are in computer ink as plus 2a squared plus 3b squared, we do need to remember to bring them down to our final answer and to combine them with any existing like terms. So we do have a 9a squared and a 2a squared, and that's how I'm going to come up with 11a squared. And then I have a -b squared and a positive 3b squared, and that's how I'm going to have a final result of 2b squared. Final answer, 11a squared plus 2b squared.